VS series. Shapetrax 3A tool. The Shapetrax 3A tool searches for the portion of the captured image that most resembles the profile information of the registered model image. The XY position, rotation angle, match percentage, and scale factor of the pattern is detected. It can also locate and count multiple patterns. Connect to the Shapetrax 3A tool simulator and play through the images. These test images will be used to explain the basic setup of the Shapetrax 3A tool. Start with image number 1 in the film strip and add the Shapetrax 3A tool. From the inspection section of the main task, we will add the Shapetrax 3A tool from the position alignment category in this example. Draw the pattern region around the target. You can optionally name the model if you'd like and change the shape. You can also use a previously saved model image if desired. Click OK when you completed drawing the region. The tool results can be confirmed in the Results tab. The count, XY position, angle, match percentage, and pattern scale will be displayed for the detected pattern. The angle is in reference to the stored model image, with the stored model image being 0 degrees. The default detectable angle range is plus or minus 30 degrees. That's more than enough for this example since this part is pretty symmetrical, but adjust that as needed depending on the target condition. Play on image number 2 in the film strip. You can see this image has 2 targets, but only one is being detected. As a default, the detection count, or maximum number of patterns to detect, is set for 1. Change this to 2. You can see it's still not being detected, but if you notice, the size is actually bigger. It's the same shape, but a little bigger. So you can use what's called scale. Scale is basically the size of the target, anywhere ranging from 2 times to 0.5 times. So in this example, we will set the upper limit range to 1.5, and you can see it is now detecting this target. You can see the scale of this pattern is 1.152, so it's a little bit bigger than the modeled image. The detection order of the detected patterns is dictated by the detection order setting under options. As a default, it's set for match ascending, but we could change this to left to right. So now they're numbered left to right. So the numbering is set by detection order, and the judge label as a default is target 0, which is the first one in the list, and that's what's displayed in the tool results. Under label results, we can confirm the information for all of the detected patterns, as you can see here. Play to image number 3 in the film strip, and you can see this target also has 2 targets, but it's not being detected. That's because the shape of this target is a little bit different. It's similar, but different. So if you desire to detect this, one thing you can change is what's called minimum match percentage. This is the minimum threshold or match percentage to detect a target. If we lower this to 30, we can detect this target. If you notice, this target has a match percentage of about 38.976. So it's much lower percent match, but we can still detect it if we adjust that minimum match percentage. Play on image number 4 in the film strip, and you can see this one has 2 targets of the same shape, but they're distorted. This can be due to camera at an angle, or maybe the part's at a little bit of an angle, so the same shape is just a little bit distorted. Now, they're currently not being detected, but there is a setting for this. It's called allowable distortion. If we set this setting to 30, you can see we are still detecting these targets, even though they are distorted. Now, the match percentage is a little bit lower, but we can still detect them by adjusting that allowable distortion setting. Play on image number 5 in the film strip, and you can see that this one has 3 targets. So first, let's change the detection count to 3 so we can detect this target. There may be cases, like in VGR pick applications, where you don't want to detect targets that get too close together. In that case, you could use what's called overlap elimination. So if we turn this setting on, we can set a percent of overlap. So if I change this setting to 10, if the targets overlap by 10 or more percent, it will just keep as a default, the best matching target. So you can see in this case, it's keeping whichever one has the better match. Or if you want to eliminate them both, you could just set this to all and it'll eliminate both targets if they get too close together. Another way to eliminate unwanted targets that get too close together is called detection target selection conditions. So I'm going to turn off the overlap elimination for the moment, and we'll go to the settings here. So what you do is you enable it first. You have up to 2 different conditions, and you could draw a region of interest. In this case, we could draw a region around the target and look for any features that invade that area and eliminate those targets. So edit the region. So in this example, what we'll do is we draw a ring around the outside of this target and look for any features that intrude in that area. So we'll set it to ring and just draw a ring around the desired area here. So what it will do is it will look for features inside this ring, and we can tell it to ignore those targets if something invades that area. So you can see in this example here, right now it's set for 0 or fewer, so it's not it doesn't want any features detected in that region. So you can see these 2 targets are eliminated because they are too close together. Play to image number 6 in the film strip, and you can see we got 2 overlapping targets. So of course these are eliminated by our settings here, so we can turn that off and show you that we can detect these if we like. So you can still detect both targets. Notice that they have a little bit lower percentage rate, but we are still detecting them if you want. Or we can turn that overlap elimination back on. And if you want to detect one of them, the best match, you can turn that overlap elimination on and then just eliminate other than the best match. So the best match is retained. So it depends on the situation, how you want that to be set. Play on image number 7 in the film strip, and you can see there are 2 targets here, but they are not being detected. They are the same shape as the model image, except they are inverted. In other words, the target is now lighter than the background. And if you remember the first case, the target was darker than the background. So you can still detect these, but as a default, this reverse detection setting is off. If we turn reverse detection on, we can detect targets that are the same shape, but reverse in contrast. Now, the reason this other one is not being detected is this is a pretty low contrast situation. So under the current settings, it is not detecting that. But if you go to feature extraction settings, under feature extraction, you could change this to automatic low contrast. And in a low contrast situation, it can pick up on that target. Open up program number 1 in the Shapetrax 3A simulator, and we'll do another quick example of the Shapetrax 3A tool. Start with image number 1 in the film strip. Our goal is to locate this target, of course, but also get an accurate angle of this smaller feature on this bigger target. From the inspection section of the main task, add the Shapetrax 3A tool. This time we'll add it from the presence-absence category. Change the shape to circle and draw a circle around the target. Set the angle range to plus or minus 180 degrees and check the operation. You can see the detection is a little unstable here. It's having trouble locating that little finer feature. So not very stable at the moment. So one thing we can do is under feature extraction, we can change the search sensitivity. We could change this to detailed, which will prioritize the stability of the tool. So you can see if we change that setting, it's a little more stable here, but maybe not quite as stable as we like it. So it's still having trouble finding that smaller feature, although it seems to be doing pretty good on that. So let's go ahead and put the sensitivity back to standard. and go back to detection. And we can do what's called rotation direction added search. What this will do is it will add an additional search, and you can have it locate a finer feature. So enable the rotation direction added search and click edit for the region settings. What we can do is we can add an additional region, pattern region, to look for this smaller feature. So we'll put it around this set screw here, this small feature. So what it'll do is the main search will locate the target, the main target, and then it will do an additional search around the circumference to locate that finer feature and stabilize our angle detection. So you can see now we're getting a very stable detection. And since we're doing this additional rotational search, we can reduce our main angle detection. So I'll put this back to plus or minus 30. And then we'll run through the parts here, and you can see it's very stably detecting the proper angle of this target by doing an additional search on that smaller feature around the circumference there where we've drew this area.